Okay, we continue. The sinusoidal waveform with a different value of frequency. Okay, this is the example. Okay, given to you the equation 5 cos in bracket 2 pi f naught t, which f naught the frequency is 200 hertz and 200 hertz and 100 hertz and 0 hertz. Okay, you can compare the first, second and third. Okay, if you can see from here, okay, the first waveform, the frequency is 200 hertz. Okay, the second waveform is 100 hertz. Okay, and the third waveform, okay, is 0 hertz. Okay, can you see the oscillation? Can you see the oscillation of the waveform? Okay, that means the first one is given to you the fastest oscillation. The second is slower. Okay, and the third one is no oscillation, 0 hertz. Okay, so the frequency is 0. Okay, from the first example, okay, we can get the t value, okay, from V peak to peak. Okay, well, from V peak to peak. Okay, from here and here, from here and here. Okay, from here and here, peak to peak. Okay, well, from peak to peak, by depending on the time, okay, sorry, the time is in millisecond. Yeah, this is millisecond. This one is milliseconds. Okay, the first one, okay, you can get the value of t by peak to peak. The value is t equals to 10 minus by 5 in milliseconds, so you can get 5 milliseconds, and the f is 1 over t, so you can get 200 hertz. Okay, so the second waveform, okay, we can use a zero crossing also. Okay, from the graph, zero crossing. Okay, so you can get the value of t by zero crossing. Okay, the first one we do the exercise by using peak to peak value. The second one by zero crossing, so you can get also, okay, the value of frequency. Okay, for example, here the t is 17.5 minus 7.5, so you can get 10 milliseconds. The frequency 1 over t, 100 hertz. Okay, or you can do by get the t, okay, by using the value from peak to peak. Okay, from peak to peak, from here and here. Okay, is okay, above of upper is okay, you can choose. Okay, so also you can get the same value of t and f. Okay, the t is 15 minus 5, you can get 10 millisecond here. Okay, you minus this one and this one, then the f is 1 over t, you can get 100 hertz. Okay, so by depending, okay, depending on the frequency here, you can see the different, the comparison of the three waveform with 200 hertz, 100 hertz and 0 hertz. Okay, this part is very important, how you recognize the equation of the cosine or sine function. Okay, example here I give you the sine function Vt equals to Vm sine in bracket omega t plus phi. Okay, what is the equation? Okay, I will describe to you one by one, okay, part by part. Okay, so what is Vm? Okay, Vm is the amplitude from your signal. Okay, Vm is the amplitude of your signal. Okay, that means the amplitude is the maximum value. Okay, maximum value or peak value from the waveform. Okay, either in positive side or negative side. Okay, the definition, it can be voltage or current. This is the peak value of signal wave or the maximum value of signal wave. It's a Vm. Okay, Vm, either we call the name is V peak, V maximum. Okay, the next one, okay, sine in brackets omega t. Okay, what is omega? Omega is the phase. Okay, phase. Omega t equals to theta. Okay, omega t equals to theta. Okay, this phase is in a radian unit. In a radian unit. Okay, in a radian unit. Okay, this phase is a phase of phasor which is defined as the instantaneous regular position of waveform. Okay, in the phasor, dia adalah dalam bentuk radian unit. Okay, for example, when you have the waveform here, okay, the equation y equals to sine x. Okay, so titik-titik kecil ni setiap plotting on your graph, okay, kita panggil dia as a instantaneous value. Okay, for example, okay, bila kita buat sin, okay, sin x, right, sin in dalam kurungan sin theta. Okay, sin theta kita masukkan setiap ni. Kalau sin kosong dapat berapa? Kalau sin kosong is 0. Then kalau sin, okay, pi equals to 180 right degrees. Okay, 180 bagi dengan 4, you akan dapat 45. So sin 45, okay, sin 45 you can get 0.707. So from here you can plotting here. Okay, when you plotting the graph, okay, you can get the value of y adalah sama dengan 0.707. Sorry, okay, so 0.07 here lah. Okay, now, okay, kalau kita nak cari sin pi, that means sin pi, sin 180 darjah sini kan, so dia bagi value sama dengan kosong. Okay, so that is a omega t plus phi. Okay, phi ni adalah mewakili phase in radian. Okay, the phase in radian. Okay, next. Okay. Choose radian setting in calculator before calculate. So you choose whether you want to use degrees or radian. So if radian, you must change your calculator in radian. Okay, phi. What is phi? Phi is a phase difference. Don't confuse between theta and phi. Okay, theta is a phase in radian unit, phase of phasor. Okay, the position of the instantaneous waveform. Okay, kalau awak letakkan sin pi plus 4, you akan dapat 0.707. Tapi kalau untuk phase difference dia berbeza. Phase difference adalah, okay, from your graph, from waveform ni, dia akan bergerak. Okay, dia akan bergerak. That means lagging or leading. Maksudnya maksudnya dia punya perbezaan daripada, kalau this case dia tak ada lagi dua waveform. Okay, dia adalah daripada reference from 0 tu berapa dia bergerak kepada the next position dia. Okay, that means tu ada phase different angle dia, maksudnya dia bergerak daripada reference tu berapa dia punya perbezaan. Okay, phase different. Okay, this phase is either in degrees or radian. Okay, dia akan boleh jadi dua bentuk, sama ada degrees ataupun dalam bentuk radian. It is the angular difference between two waveform or phasor. Kalau dia tak ada dua waveform, bermakna dia satu je waveform kan. Makna daripada reference point daripada 0 tu, ataupun kalau untuk sin daripada 0 lah. So berapa dia berubah untuk second waveform tu yang dia bergerak tu kan, berapa dia punya perubahan phase different. Okay, so that is a phase different. Don't confuse between theta and phase different. Okay, formula to change radian or degrees. Okay, ini adalah yang penting juga. Okay, you kena guna formula ni lah. Okay, pi equals to 180. Okay, pi equals to 180 degrees. Pi bentuk radian. Okay, degrees bentuk dia 180. Pi sama dengan 180 radian. So kalau nak buat pertukaran daripada radian ke degrees, you kena gunakan formula ni lah. Okay, formula ni you kena gunakan. Okay, contoh yang pertama. Okay, example 1. Given a sinusoid IT equals to 5 sin in bracket 4 pi t minus 60 degrees. Okay, in this question, it wants you to calculate the amplitude, phase, angular frequency, period t, frequency f, and the value of IT if given t equals to 10 milliseconds. Okay. Solution. Okay, it's given to you the equation. Okay, 5 sin in bracket 4 pi t minus 60 degrees. Okay, this is our reference equation. Okay, I am sin omega t plus phi. Okay, very direct, very clear. It show you. Okay, you can compare from our reference equation, so you directly can get the amplitude. The maximum value is 5 here. Alright, 5 ampere the amplitude. Okay, the phase difference in degrees. Yes, you can get the phase difference in degrees is 60. Okay, your reference is plus, right? So now in minus, so you put the minus 60 degrees. The third one is angular frequency. Okay, angular frequency is omega. Okay, angular frequency is omega. Frequency is f. The angular is in omega. Okay, ingat f is Fourier frequency, but omega omega is W 2 pi f. Okay, so yang ketiga kita panggil dia angular frequency. Okay, unit is radian per second. Okay, clearly, okay, you can get from the equation for 4 pi. Okay, omega is equal for 4 pi. Okay, here. The third one, it was the value of period. Okay, how to get? Okay, the answer is t 0.5 second. Okay, here I show you the jalan kerja dekat sini. Okay, how to define? You know omega equals to 2 pi f. Okay, omega equals to 2 pi f. Okay, so f kita balikkan dalam equation tu, you can get omega over 2 to 5. Okay, you know t equals to 1 over f, right? So you put the equation here, t 1 over f. You put the f equation here in here. Gantikan dengan f ni, so you can get t equals to 0.5 seconds. Okay, so you dapatlah jawapan 0.5 second. Okay, how to get the frequency? Okay, reciprocal kan, f equals to 1 over t, you dapat 2 Hz. Okay, 2 Hz. Okay, the value of it when t equals 10 millisecond. Okay, 10 millisecond. You can get here 10 millisecond, it 10 millisecond. Okay, dekat sini you just masukkan value dalam equation yang sekarang lah. Okay, you masukkan, so you masukkan sini 5 sin, okay, 4 omega, gantikan t tadi. Okay, t sama dengan 10 millisecond kat sini. Okay, now your equation, now you kena decide lah. So 0.126 dalam bentuk radian. Okay, 60 in degrees. So which one you want to use, either in degrees or in radian? So you must select it first lah. Okay, so conversion degree to radian or radian to degree, use this formula. So pi equals to 180 degrees. Okay, so from here I want to use in degrees, so I must convert first 0.126 in degrees first. So I convert pi rad equals to 180 degrees by using this formula. So saya dapat 0.126 radian, convert to degrees, 0.126 multiplied by 180 degrees over pi, I get the in degrees is 7.22 degrees. Okay, so then in my calculator I use in degrees now. Okay, so you just put the value in degrees. Okay, so now you can subtract with the 60 degrees directly by using your calculator only. So you get the value is it equals to minus 3.98 ampere. Okay, this example, when we convert the radian here, omega, in degrees. Okay, this is the step. Okay, then it equals to, now in 10 millisecond, the value of it is minus 3.98 ampere in 10 millisecond. Okay, let's try by using radian conversion of 60 degrees. What's the answer? Okay, if you want to convert to radian, 0.126 no need to convert, you must convert the 60 minus 60 degrees, the 60 degrees in radian. Okay, so the first one we use the radian. Okay, but the second one I want you to convert in degrees, in radian. So 60 degrees convert first in radian by using this formula, and you can get the same answer of it.